Hello friends, welcome to all. Today we are going to discuss electricity. Now, what is electricity? Why we have to study this? So these are the question arises. So electricity is nothing but it is a one form of energy, like a solar energy, wind energy. It is also one form of energy. In modern society, why we are using electricity in the most of the places? For example, in your school, in our homes, everywhere we are using electricity. So there are some advantages of using electricity. Electricity is a very convenient and controllable form of energy. Because of this, we are using this electricity everywhere. So we will discuss in this chapter about electricity, basic concepts of electricity, and practical uses of electricity. Now, first we will discuss about electric current. What is electric current? So, before starting this, I will like to discuss about water current. Okay, what is water current? It is nothing but flow of water is known as water current, right? Then somewhere we can say that air current. So flow of air is known as air current. So same way in electricity, electric current is nothing but flow of charges. Okay, so in this figure we can say this one is the conductor and this Q's are the charges and it is flowing towards this arrow direction. Okay, so whenever the electric charge flows in the conductor, we can say that there is a electric current. Okay, so electric current is defined as rate of flow of charges. Rate of flow of charges means what? For example, in 1 second, some amount of charges is flowing from the conductor. So that is a rate. Okay, in 1 second, how much charges are there flowing from the conductor? Okay, so this way we can define the electric current. So in simple way we can say that current is nothing but it is a flow of charge. And I think you already know that there are two types of charges are there. One is positive charge and one is negative charge. Conductors. What is conductor? So in simple way we can say that conductor is a substance from that electric current can flow easily, right? So the substances through which electricity can flow are called conductors. Some examples are, for example, copper, aluminium. Almost most of the metals are good conductors, right? Gold, silver, all are the conductors. Here examples are given: silver, aluminium, copper, alloys such as nichrome, carbon in the form of graphite. So we know that there are different form of carbon. So graphite form of carbon is also one type of conductor. So there are so many things, so many metals and alloys are available that are good conductors. Good conductors means current can flow from the conductors easily. That is good conductors. So we can say that resistance of good conductors are very low. Here you can see some examples. This is the copper wire, the gold plate. This is the aluminium wire. Okay, these are also some examples of wire. So generally, electrical wire are all good conductors. Now, electric circuit. What is the meaning of circuit? So here you can see one electric circuit. Only three components are there. One is lamp or bulb. This one is battery. You can see here plus and minus. So we already know that in battery there are two terminals. One is positive terminal, another one is negative terminal. It is also known as cell also. We can say only one battery, one cell is there. If number of cells are connected in series or parallel, we can say that it is a battery. So we can take a DC power from the battery. So positive terminal is connected to lamp. Negative terminal is also connected to lamp through this device. What is this? It is a key. You can say that it is a key. Here this key is in a closed position. So this is the closed circuit, right? So a closed and continuous path, you can say that path is very close and it is continuous. So closed and continuous path along which and electric current flows is called an electric circuit. So we can say that this one is the closed path and current can flow from this path. Okay, so this is known as electric circuit. Now open circuit. What is meaning of open circuit? Here you can see one circuit diagram. One battery is there, one lamp is there, and connection of this battery to this lamp is not in both ends. One wire is cut out here. Okay, so this is not a closed path. Okay, we know that what is electric circuit? Complete electric circuit means it should be closed path. So it is not a closed path. So we can say that it is a open circuit, right? So an electric circuit through which no current flows is called open circuit. So this is a gap. Due to this, current cannot flow through this circuit. So this is a open circuit. Now example of closed circuit. Here we can see current is flowing through this circuit. It is a closed path. So current can flow only through the closed path. So this is a closed circuit. Now what is insulator? Insulators are the substances through which electricity cannot flow. It means in some materials, from some materials, electricity cannot pass. For example, rubber, ceramic, wood. So all are the different form of insulators, right? Example of glass, ebonite, rubber, most plastics, then paper, dry wood, cotton, mica, bakelite, porcelain. So these are the examples of insulators. Now question is, what is the need of insulator in electricity, right? We know that conductor is important because current can flow from the conductor. But what is the need of insulator? So insulator is used for the security and protection purposes, because we know that if we touch the live wire, we can get current and we can get shock, right? So due to this, we are using this rubber or plastic materials for the protection purposes. We have already seen the electrical wire. So in the electrical wire, outside layer is made from rubber or plastic materials, and inside this there is a metal like copper. Okay, so this is very important in electricity. These are some examples. You can see this is plastic, wood, this is a ceramic sheet, this is a resin sheet. So these are the examples, and I think you have already seen this. How is electric current expressed? See, In mathematics there are some expressions. By using expression we can express different formula, different equations. So now the question is, how can we express electric current, right? So electric current is expressed by the amount of charge flowing through a particular area in unit time. It means how much charge flowing from particular area of a conductor in some time. So three factors we have to consider. One is the amount of charge, another one is area of the conductor, and third one is time. Okay. Now what is the conventional flow of electric energy? Means how electric energy or electric current is flows. So here we can see one figure, A and B, 2 points are there. This is a minus signs are electrons and plus signs are positive charges. Okay. So electrons are flowing from left to right. So this arrow is represents flow of electrons. And electric current means positive charges are flowing from B to A. Okay, so it is the electric current. So we can see the direction of both these are different. It means if the electric current direction is from B to A, then flow of electrons will be from A to B and vice versa. Okay, so the electric current flows from a region of higher potential to a region of lower potential. Means higher potential region to lower potential region may flow current. That is in a direction opposite to the direction of flow of electrons that we have already discussed. Right? Now formula for current through a cross section. Cross section means area, cross sectional area of the conductor. So this is very simple formula. Okay, I is equal to Q upon T. I means current, Q means charge, T means time. Okay, so from this simple formula we can find current. SI unit of current is ampere. Okay, SI unit of Q is coulomb, means Q means charge. So SI unit of charge is coulomb, and SI unit of time is second. Okay, not minute, not hour. Second is the SI unit of time. So we have to use SI unit for this. SI unit of charge, okay, that is coulomb, and it is denoted by capital C, right? He is Mr. Coulomb. 1 coulomb is equivalent to the charge contained in nearly 6 into 10 raised to 18 electrons. It means in 1 coulomb of charge there are 6 into 10 raised to 18 electrons are there. Okay, so this way we can define the charge, but you have to keep in mind this thing. SI unit of charge is coulomb. Charge of an electron, we know that charge of electron is negative. Okay, so electron has a negative charge of 1.6 into 10 raised to minus 19 coulomb. It is defined. Okay, unit of electric current. Okay, electric current is expressed by ampere and denoted by capital A. He is Mr. Andre Mary Ampere. So for the honor of Andre Mary Ampere, we have taken the unit of electric current is ampere, and it is denoted by capital A. Now, how can we define ampere? The electric current flowing through a conductor is said to be 1 ampere when 1 coulomb of charge flows through a conductor in 1 second. So we have already seen formula I is equal to Q upon T. Okay. So if we have to define 1 ampere current, then 1 coulomb of charge flows in a 1 second is known as 1 ampere current. Here we can see I is equal to Q upon T formula is there. Okay. So 1 ampere is equal to 1 coulomb charge divided by 1 second. Now, what are the other unit of electric current? Milliampere. Milliampere means 10 raised to minus 3 ampere. So it is a smaller unit of current. Another smaller unit is microampere. 1 microampere is equal to 10 raised to minus 6 ampere. Okay. So it is a very small amount of current. So small quantity of current is there. For example, we are talking about in our mobile phones. There are very less amount of current is there. So for smaller circuits, we have to define the current in smaller units. Now ammeter. Here you can see one meter. Okay. This is known as ammeter. So how can we decide this is ammeter? Here you can see A. Capital A is there. Okay. So this A is denoted by ampere. It means this is an ampere meter. We can measure current through this meter. So the instrument used to measure current in a circuit is called ammeter. Okay. This one is the analog type ammeter. So we have to keep in mind this thing. Current can measure by using ammeter. That is an instrument. How is an ammeter connected in a circuit? Ammeter is always connected in series. Okay. You have to keep in mind this thing. Ammeter is always connected in series. For example, here we can see that this ammeter is connected in series. Why should an ammeter have a very low resistance? So, ammeter is connected in series. It means almost all the current flows in a circuit is flowing through the ammeter. So, if the resistance of the ammeter is high, then there is a very high amount of power loss will be there. Okay. So, due to this, the resistance of ammeter is very less. Since the entire current passes through the ammeter, it should not change the value of current flowing in the circuit. See, by Ohm's law we can say that whenever the resistance is high, current is decreases. It means current will change. So it is not convenient for us. So due to this reason, ammeter have a very low resistance.